Hi, future doctors. Welcome to the next class. So, we were discussing magnetic moment of a magnet. So, now in this class, we will see if magnet is bent in the arc shape. Then, what is the resultant magnetic moment, net magnetic moment of this magnet if it is making an angle theta? So, already we came to know magnetic moment direction south to north. What is the magnetic moment formula we gave? M into 2L or 2A. If we are taking this is A, M into 2A. Correct? So that is the magnetic moment of short bar magnet which is in linear shape. Now we are bending this magnet into arc shape like this. Now, what is the new magnetic moment of this? Okay, how we are going to calculate? Now, what is the length of this? L is going to be and theta. And this is going to be radius r. Arc length radius theta. We came to know theta is equal to L by R. L is going to be theta R we came to know. Next, what is the magnetic moment definition? M dash equal to pole strength. Small m into distance between these two poles. So, what is the distance between these two poles means? Let us assume this is x. M into x. How we will calculate x means we will divide this, then this is going to be theta by 2. This is going to be x by 2. So for theta by 2, this is which side? Opposite side. Therefore, I am taking sin theta by 2 is opposite side by hypotenuse. Therefore, x by 2 is equal to r sin theta by 2. Then x equal to 2r sin theta by 2. Substitute this x in this equation. And m dash equal to small m into what is x we got? 2r sin theta by 2. Derivation is not required for us, only formula is going to be important. Final formula is going to be important. Now, what is capital R? How we can write means capital R is equal to L by theta. So, what is the length from south pole to north pole we have taken? Length is going to be 2A. Therefore, this is going to be L is going to be 2A. Therefore, in place of this L, 2A by theta we can write. In place of this L, 2A. South pole, north pole distance is 2A. So, M into 2 times of capital R, you can replace as 2A by theta into sin theta by 2. What is small m into 2A we came to know? Small m into 2A is nothing but capital M. 2m sin theta by 2 by theta. So, how to remember this equation? Means already we discussed in first year in circular motion, an object is moving from one position to another position by making an angle theta. So, what is the displacement formula? 2r sin theta by 2. For this extra will be theta is coming. So, 2m sin theta by 2 by theta. So, one linear shaped wire south north. This magnetic moment is bent into the arc shape which is making an angle theta. Now what is the new magnetic moment of this means now m dash equal to 2m sin theta by 2 by theta. So very important problem. South to north its direction. Very important equation. 2m sin theta by 2 by theta. So one of the year they asked theta is given 60 degrees. Then what is the new magnetic moment? Theta is given 60 degrees means 2m sin 60 by 2 by 60 can be written as pi by 3. Correct? Pi by 3 is 60. So if you cancel, this is sin 30. Sin 30 value 1 by 2 into pi by 3. 2 cancel, 3m by pi. If they have given 30 degrees, how to solve that? 30 is nothing but 2m sin 30 by 2 by pi by 6. Now sine 15 degrees we have tried. So that one only we discussed in our basics. Sine 15, cos 15, 75 and all this. Now this linear one is bent into the arc shape. So this is m, this is m dash. What is m dash we got? M dash equal to 2m sine theta by 2 by theta. Now this arc shaped magnet is bent into the straight reverse of this. Then what is the new magnetic moment of this? Old magnetic moment of this? M. So what you will get means from this formula, M is going to be m dash theta by 2 sine theta by 2. This is the formula. So this is also going to be very important. Now we will see one simple problem you can do easily. So this is south-north magnetic moment. It is bent in the form of semicircular arc shape. Then what is the new magnetic moment of this? This is m. So now what is the new magnetic moment of this m dash means? Now what is the angle here? So here angle is going to be 180 degrees. So here theta, here angle is 180 degrees. Then m dash equal to, from this formula, 2m sine 180 by 2 by, what we have to write? Pi. 180 degrees means pi. So 2m by pi, this is sine 90. Sine 90 value 1. So therefore, new magnetic moment is 2m by pi if it is bent in the arc shape. Next, see how they may ask questions. So this is a magnet of magnetic moment, capital M. Now this magnet is divided into two equal parts by cutting parallel to its length. Now one of the part, so this is above part, south pole, north pole. So one of the part is bent into the semicircular arc shape like this. This one they place as it is like this. Okay, this is south, this is north. Now one of the part is placed like this, south, north. So the second part they place like this, south, north. Now two parts, first part, second part. Now both the parts, this is second part they bend. Now both the parts bend like this and they place it like this. North, south, north, south. Now both the parts they place like this. Now what is the net magnetic moment they will ask. Now whenever they place it one by one we will see. So if they divide it parallel to its length, then what is the new magnetic moment of first part? First part is m by 2. Already in previous class we discussed this. Now this is also m by 2, but they bent in the semicircular place. So semicircular one they bend means m dash equal to what is formula? 2m sine theta by 2 by theta. Now what is capital M here? If it is original one means capital M, but second part magnetic moment is m by 2. First part also m by 2. But they bend, therefore in place of m what we have to write? M by 2. Therefore 2 times of m by 2 sine 180 by 2 divided by pi. So 2 will be cancelled. Sine 91. Therefore m by pi. Correct? So m by pi is the magnetic moment of this semicircular arc shape, which is second part of the original magnet where we have removed or cut, isn't it? Now what is the magnetic moment of this? M by pi. Now see the directions. This is south to north, south to north. Both are in same direction. Same direction means always you have to add. Therefore, new magnetic moment. So m dash equal to, so m by 2 plus m by pi. So 1 by 2 plus 1 by pi. So m into 2 pi is LCM, pi plus 2. Isn't it? That is for this. Next, for this, already we calculated this semicircular one is m by pi. So this is south to north, m by 2. This is m by pi, south to north. What is the angle here? 90 degrees. 90 degrees means how we have to find resultant? Root of m by 2 whole square plus m by pi whole square. Again, you should not ask how this formula came. Already we discussed in previous classes. Next, see here. This is south north like this, south north. Both are in same direction. Now semicircular one, how much we got? M by pi. Therefore, this is also m by pi. This is also m by pi. Both are in same direction. Therefore, what you will get? M by pi plus m by pi. You will get 2m by pi. So in this you can see south north. This is south north. Angle is perpendicular. This is m by pi. This is also m by pi. Therefore, m by pi whole square plus m by pi whole square. Now, what is the final answer? 2 times of m by pi whole square. So, root 2 m by pi. This is the net magnetic moment if they bend one of the magnet into arc shear. So, this one we don't know how they may ask. So, we should be ready with any model. So, still you can practice on these models. If a magnet is going to be divided into 3 equal parts, so 1, 2, 3, then each magnetic moment is m by 3, correct? Because 3 parts, 2 parts means m by 2. Therefore, m by 3, m by 3, m by 3. Now, 2 parts they have taken first part like this, north pole, south pole. Second part like this, north pole, south pole. Third part like this, north pole, south pole. So now what is this value? M by 3. M by 3. Now what is this one means? M dash equal to 2m sine 180 by 2 by pi. What is m here? M by 3. Therefore, 2 times of m by 3 sine 90 by pi. So, 2m by 3 pi. So, this final one is 2m by 3 pi. Its direction is south to north, south to north, south to north. All you have to add. So, sometimes 2 they bend. Let us assume this is first one. So, these poles are going to be very, very important. This is second one, north, south. This is third one, north, south. So, this is 2m by 3 pi means this is also 2m by 3 pi. So, like that their own wish they are going to give. But whenever they are giving, so this north, south, north, south, north, south is going to be very important. If directions are in same direction, north, south direction, you have to add blindly. If both are in opposite direction, you have to subtract. If you remember like this, resultant magnetic moment, any question you are going to solve. So still we will discuss in upcoming problems. So we will do next concept in next class. I hope you people understood. You can practice more models, then definitely you can do. And then last year they asked this question. How they asked means 2024. North, south. A magnet of magnetic moment is bent at its center in such a way that it is making an angle. It is making an angle 60 degrees at center. Then what is the resultant magnetic moment of this magnet? So, resultant magnetic moment means we give two formulas for us. Root m1 square plus m2 square plus 2m1 m2 cos theta. Another one is m1 square plus m2 square plus 2m1 m2 cos theta with minus. One is with plus, another one is with minus. So, which formula we have to use? So many students made mistake. So they came to know here they won't give same poles or opposite poles. If they bend at center, So N will be going here, S will be here. Then which poles will be available here? So here it is south pole, here it is north pole. Same poles or opposite poles? Opposite poles touching each other. Then you have to use here minus. Now what is the magnetic moment of this? M1, M2. They bent at center. Center means it is going to be divided half. So therefore this is M by 2, M by 2. Therefore M1 is equal to M by 2. M2 is also M by 2. Now substitute in this. So sometimes if they don't know same poles or opposite poles, they have taken here cos 60 with plus. Then you will get wrong answer. So m by 2 whole square plus m by 2 whole square minus 2m by 2 m by 2 cos 60. So what is cos 60 value? M by 2 whole square plus m by 2 whole square minus 2m by 2 whole square cos 60 value 1 by 2. So 2 will be cancelled, 1 m by 2 whole square will be cancelled. Finally answer is m by 2. So resultant magnetic moment is m by 2. So they may give 90 degrees. If they give 90 degrees, root 2 times of m by 2. They may give 120 degrees. So you can cross check how much you are going to get. Like this you have to practice, then definitely you are going to get the answer.